Hi, everyone. Today on Zoom, we were supposed to finish up our notes on section 4.2, the unit circle. And since I'm not going to be there today, I just wanted to do a real quick video on it so that you guys have it to go off of. Okay, so you can find it under video and notes. It is right here. It will post tomorrow morning, and you're just going to click right here for the notes, and it should be a very, very simple note. So this is to find coterminal angles that fall in the unit circle between 0 and 2 pi, 0 to 360 degrees, and then to be able to evaluate these trig functions using our definitions. So just a real fast review of our definitions, okay, which we should already know these, but if we've forgotten, okay, cosine goes with the x value, sine goes with the y, and tangent is y over x. Okay, then we have cotangent is x over y. Remember that I'm going to underline cotangent and tangent because those ones we're only talking about the numerators. Okay, we talked about that trick in the last lesson. Okay, sine, mi casa es su casa, or Santa Claus, the S and the C, they're partners, so they go together. So the definition is 1 over y, or you could simply flip the y value. Okay, and last but not least, using that same Santa Claus or mi casa es su casa, the cosine and the secant, the C and the S go together, they're partners. This is 1 over x. So we are going to do the 1 over the x, or simply just flip the x value. Okay, so doing part 2 of the unit circle for this day 2 notes, same definitions. Okay, basically what we're looking at is angles that do not fall between the 0 to 2 pi or 0 to 360, meaning they're not shown exactly on the unit circle. Okay, so like for example, what if I had negative 11 pi over 6 as my angle? What if it's negative? Okay, well, what we want to realize is I can add a coterminal angle. Okay, so we could add 2 pi if we are in radians. Okay, so that would be the ones that have the pi's in it, or 360 degrees if our angle is in degrees. Okay, so if you guys remember, this is called finding a coterminal angle. Okay, so where it starts off at, and then we're just doing one full rotation. And basically what it's doing is it's taking this angle. If I add 2 pi over 1, okay, it's rotating it one time in the the counterclockwise direction, and then it's making it in between the 0 to 2 pi area, okay, in that domain. So what's my common denominator? My common denominator is 6, so I'm going to now make this a 6 on the bottom. This then becomes a 12 pi, and then what happens is I slide my 6 over, and then I have negative 11 pi plus 12 pi, which is just 1 pi, or I just like to write pi over 6. Okay, so then once I have that, these two angles are coterminal to each other. They're exactly the same. Okay, so what I need to remember is okay, well, where is pi over 6? So I'm actually going to use this unit circle here, and I realize that pi over 6 is right here, so 30 degrees, and I need this point in the first quadrant. Okay, so I'm going to write that down. This is quadrant 1, and my point is radical 3 over 2, comma, 1/2. Okay, and now we're just going to go through all of our definitions. Okay, just like we've done in the past. So my first definition is cosine. Cosine goes with the x value. So this is going to be radical 3 over 2. Sine goes with the y value. So this is going to be 1/2. Okay. Tangent goes with y over x. Remember that all we're looking at is the numerator. So I'm taking 1, putting it over the x numerator, which is radical 3. And then we rationalize. So times it by radical 3 to the top and the bottom. And we're left with radical 3 over 3, okay, for tangent, right? Then I'm going to go over to my reciprocals. Okay, for secant, instead of doing 1 over x, all I want to do is flip the x value. So I have 2 over radical 3, rationalize, and I get 2 radical 3 over 3. Okay, cosecant is the reciprocal of sine, so it's going to give us 2 over 1, or 2. And then cotangent, I'm going to do x over y, or flip this, so that's going to be radical 3 over 1, or just radical 3. And then we're done. And because we're in the first quadrant, everybody is positive and happy. Okay. Same thing over here for number 2. All right. We're just going to add 2 pi. I'm going to do this quickly. My common denominator is 2. So I'm going to make this 4 pi over 2. And that gives us pi over 2. Okay, once again, pi over 2 is actually the same as 90 degrees. So if I was to take a look very quickly at my unit circle, that's up here at the top y-axis, 0, 1. So this technically is not in a quadrant. Okay, so this is positive y-axis. Okay, and my point is 0, 1. Okay, and then once again, you go through, try to beat me if you can. So cosine goes with x, which is 0. Sine is y, which is 1. Tangent is y over x. So that's going to be 1 over 0. But remember, 0 is not allowed to hide under the denominator, so it's undefined. Okay, and then I'm going to come over here to secant. Now, to me, it's easier to do the definition 1 over x for this because I can clearly see that 0 is hiding, which is undefined. Okay, then I go to cosecant. Cosecant is 1 over y, or 1 over 1, and that's 1. And then cotangent is x over y, which is 0 over 1, and 0 divided by anything is just 0. Okay, so there you have it. Just a little extra practice of what we just did. Okay, all right. And last but not least, the last thing we have to talk about is what if my angle is outside of 2 pi, meaning it's bigger than 2 pi. So it's not negative, but it's also not falling on the unit circle. So for example, 11 pi over 3, if I take a look, okay, I only go up to 5 pi over 3. So 11 pi over 3 is not on here. Okay, so what I need to do is I could do the same exact thing, except this time I'm going to subtract 2 pi. Okay, because I want to make the angle smaller. So I'm going to either subtract 2 pi if I'm in radians or 360 degrees if I am in degrees. Okay, so this one's in radians. So I'm going to do 11 pi over 3 minus 2 pi over 1. Once again, we have to get a common denominator. Okay, we spent a long time on this in the beginning of this section. So 3, 6 pi, so 11 pi's minus 6 pi's is 5 pi's over 3. Okay, and that is, if I go back to my search here, 5 pi over 3 is in the 4th quadrant, and here's my point. So I'm just going to write that down. Here's 4, and that gives me 1/2 negative radical 3 over 2. Okay, and then you just go through and do your definitions once again. Okay, if we were in class, I'd have you guys do these, on chat. So cosine is the x, 1/2. Secant is take the reciprocal, which is 2. Sine is the y value. Cosecant says flip it, so that's negative 2 over radical 3, which is rationalized, negative 2 radical 3 over 3. Tangent is y over x, so negative radical 3 over 1. And then cotangent, the numerator of x, all over the numerator of y, and then rationalize. Okay. All right, and there you have it. Last one over here, I'm just going to kind of write out 13 pi over 4. So I need to subtract my 2 pi. All right, and that's going to give me 8 pi over 4. And that is going to be 5 pi over 4. Once again, I know that this is going to be a 45 degree triangle. So 5 pi over 4 is right here in the 3rd quadrant. Point is the same. So here's 3rd. So since it's in the 3rd, I know both of them are both going to be negative. And it takes me longer to write this down than to talk. All right, so cosine is going to be negative radical 2 over 2, which is going to be the same for sine. Okay, tangent is just going to be the y numerator all over the x numerator. So if I have the same exact thing, okay, it's going to cancel out to give me 1. Okay, so please be careful with that. It's in the third quadrant. Tangent is positive in the third quadrant, so that's why it's a 1. So that means cotangent has to be the same. All right, now secant and cosecant will also be the same. Okay, so what we're going to do is we're going to flip this. So it's going to be, we know it's going to be a negative. Okay, so we're going to do -2 over radical. Oops, sorry, I'm going to flip it. Oh, wait, yes, I did. -2 over radical 2. So over radical 2 and rationalize. So I just want to show you how this does. Radical 2 over radical 2. Okay, and that gives me -2 radical 2 over 2. And then what happens is the 2's cancel, and we're left with a negative radical 2 for both secant and cosecant. Okay, so the 45, 45, 90-degree ones are actually very simple because they end up to be the same answer. Okay, and there you have it. So it's exactly the same thing that you were doing before. It's just you have to play with the angle first so that you can find it on the unit circle. Okay. Last but not least, what I wanted to show you real fast is one of my lovely pre-calc students was nice enough to share with me how some tricks for finding angles, okay, which is in this YouTube video right here. You might find it useful. It's a little shortcut trick, 3 minutes. Hey, you might like it better than my notes, so go ahead and give it a try. And then I gave you like a little 5-question real quick game link. To check it out and a little extra practice to see how you're doing with this material. All right, there you have it. See you later.